Thanks, Tim. That was an awesome talk, and I think some of your stuff could really help with some of the stuff that we did as well that I'm about to talk about. So, I'm here today to talk about our journey of upgrading our core network. So, who am I? Some of you may know me, Jarryd. The reason why I'm wearing this is I'm actually really cold down here. I'm based in Darwin, so it's a bit rough. I've been a systems engineer and also network engineer for approximately 15 years, and I'm currently the National Engineering Manager at Opticomm. I previously held roles at Vocus, Aussie Broadband, Over the Wire, and DigitalOcean. So, who are Opticomm? Well, we're a competitor to many different access fibre networks in the residential market. Direct competitor, of course, to the National Broadband Network. And our aim is to connect our customers to the internet via our partner RSPs. So as mentioned, today I'm talking about our upgrade journey. And the reason I'm talking about this is in July 2023, we had a configuration change that we committed in the network in New South Wales, and it triggered a large-scale outage. At the time, we were running extended end-of-life software versions, and those software versions were no longer supported by our vendor. Something I'm sure many of us have skeletons in our closet in our networks. Known software defects were preventing our ability to upgrade to newer versions over the previous few years, and this is really talking about our process and managing the challenges of upgrading a national access network, which at the time, when we upgraded the network software, impacted 100% of our customer base over this journey, which is a mammoth effort with very little issue at the end of it, thankfully. So something that some people have asked for is what our network looks like. It's a very high level, I do apologise. Can't go into too much detail. But we operate 2 points of interconnect per major state. We do aggregate some of those, like Canberra, for example, back to New South Wales, and POI A and POI B. So we don't operate the 121 POI model like one of our competitors. I think it's a much better idea to do this. Some will disagree. We have, the benefit obviously carrying that traffic for you to a central location, and you don't have to get your own backhaul to those sites, which I think maybe it was the TPG guys earlier talking about the cost of doing so is very expensive. So what happened? Well, the routine network configuration change was to commission a new site in our network. And this is something we do all year, anytime a new suburb is built that we have a contract for. It's something completely standard. It's a network change that we often do, and it's a standard process for us. At the time, our monitoring system began to generate thousands of alarms, indicating there was a very large outage across our entire New South Wales network. The core network device in question was responsive to SSH, however, every single card in the box has stopped forwarding traffic. This meant that customers were offline, and we were getting the complaints flowing fast. And all FPCs in this device showed 100% CPU utilisation when we checked it. And this is just a snapshot of the logs. There were over 9,700 log messages generated for this one device. It was horrible to read, but indicating essentially every LSI went down and the device was busy. Simple as that. So how do we respond? Well, the first thing we did was roll back the network change. Like everything, we assumed that we made a big mistake. We knew that we committed a config, and it had to definitely be us. We implemented a network-wide change freeze. This is something we took as a stopgap, first of all, to immediately address the concerns going on in the network, not to put extra load anywhere else in the network where we were short on engineering resources to ensure we could adequately address this issue. We collected those 9,700 plus many other log messages, and we did review those by hand, line by line, to find any obvious signs of a problem. Of course, we complete the common troubleshooting and log detection and debug steps that you do when you have something like this occur. Check if interfaces are up. I think Tim just mentioned before, there's a lot of cool tests you could use to do this. Might be something my engineering team could look at. And we collect this information as well in the event that we do need to raise a case with our vendor. So we know that there's going to be a show tech or an RSI or something we have to collect in the network if they require it. So we completed that step. We obviously review the configuration change that we made in detail. This is something we do, we do implement a change management process as a part of this. So we have a documented step-by-step MOP change. It's been peer reviewed, and this gives us the ability to go and check, have we implemented something incorrectly? Basically, did we stuff up? And our investigations in this yield no obvious signs of a human error when we review this, and the configuration was identical to our standard commissioning process we use everywhere in the network. So we implement the same change. This was a hard decision to make. We were obviously in a change freeze as a stopgap, but we needed to actually try and reproduce this issue again with our vendor so we could ensure that we understood what was going on, because there were no obvious signs of us causing a problem. We scheduled it in an outage window, and we took further logs and debugs, and we also did pre and post checks just to see if something did go wrong, what was the state before and after. And this time, change went through without an absolute hitch, no alarms, nothing, and we all had very puzzled looks on our faces. So this kind of gave us a bit of a false sense of security that maybe we just hit some random event, it was never going to happen again. Solar flare, perhaps, who knows? That was a joke, by the way. Fast forward to Friday, the 13th of October, and if you're superstitious, I'm a little bit superstitious, this issue reoccurred on that night. It was absolutely horrible, alarms going off left, right, and centre, and it's something we hadn't seen since July. So this time, the trigger was different. A backhaul interface in our network flapped once, and thousands of network alarms were generated. Same outage, the entire state of New South Wales offline again. Very angry customers, very angry internet providers, very tired people on call waking up. This time, we take no chances. We immediately engage our vendor again, this time with a P1 support case while the issue's occurring. And we're hoping to capture some extra logs that they might require while the issue's happening. So what was wrong here? Well, really, at this point, we need to rewind to May 2023. We'd actually known that we were going to encounter issues with software support, that we were going to hit an end-of-life milestone. So we'd already been working with our vendor to upgrade our software or come up with a plan to do so. Unfortunately, we did have limited support on the current version, and full credit to our lovely Juniper account team, I think some of them are here today, they still helped us to at least restore the network, which is their main goal. Let's get the network back up and running and then figure out what we can do from here. So why is that a challenge for us, however, that we've encountered this? Well, this time it's a new trigger and one that we don't have control over. We can't implement a change freeze to stop a backhaul flapping, unfortunately. So it increased risks, adds more time pressure, and we need to really find a resolution to this quickly. We knew that with our works with our vendor in May, we'd experience large challenges upgrading this in what we call a simple manner. And why? Problem reports, bugs, that's right. So something I'm very passionate about is a bug-free network. Reality is it's never going to happen. Very complex devices, as a few other people have mentioned here today and yesterday. And every scenario is different, every carrier operates different functionality. So this is where our journey really begins. So our vendor has, through their help and also our testing and the collection of information we've had, we worked together to identify what we think was a scaling problem or potentially related to the design of our network combined with the configuration we employ. Every time that this device either does a commit or has some kind of backhaul flap, we use VPLS. Hope I don't get shunned too much for that. The box has to do potentially billions of hardware reprogramming events. Reprogram the FPCs. The PFE has a lot of work to do, and that network convergence can cause quite a big strain on the box. We also know that the old code that we were running is actually not optimized for managing the scale of our design effectively. So with our VPLS configuration, without going into too much detail, each of our internet providers, RSPs, have a routing instance in our core network. That routing instance is a VPLS routing instance, and we use apply groups to apply every single VPLS peer to every single routing instance. Yes, it's not the best way we can design the network. Yes, it's also very hard to change that when you've already got a very large network. So this means that every time a commit is done on the box in the old code, the code actually dynamically reapplies every single neighbor to every single routing instance, irrespective of if it's changed. In a newer software version, that doesn't happen. We'll talk about that in a moment. So the new code is optimized to scale better, as I mentioned, and this one big factor was reconvergence events don't have to necessarily reprogram the FPCs when something changes, when something doesn't change. So only if it changes does something need to be reprogrammed. This reduced the scale of the reconvergence event significantly and was one that we believe was going to help us in the network. So we kick off a major project to test and validate and deploy one of the recommended releases from our vendor, which at this point in time is 22.2 R3 and the latest S release. We were on 18.4. So we knew this was going to be a big exercise. The 4 PRs from the previous slide had already prevented us upgrading in the past. Why? Because those 4 PRs directly impacted VPLS. Every single one of them would cause our network to fail again. We had tested this, we have upgraded in the past, and we did encounter issues and have to roll back. The first version that all 4 PRs were fixed in was 20.2, and 20.2 was going to be end of support at the end of the year as well, 30th of December. So we knew we had to go further than that. We must reach 21.2 at a minimum if we want to stay on extended end-of-life releases. And of course, the release structure has changed recently by Juniper, but 21.2 is where we had to hit at a minimum in a single upgrade night to know that the network was going to be stable for us to operate and at least leave for a few days. So the standard upgrade path, this is where it gets horrible. You normally download the next release. You can't skip too many releases. You have to upgrade one routing engine. We're using dual routing engine systems. You have to adhere to the rules of not skipping versions. Generally speaking, you can do 3-point releases in a night, or in an upgrade, and that's due to both potentially breaking changes in the software versions and also just different testing that's been done. I won't go into too much detail on that. We can chat about that separately. This means that we had 6 upgrades needing to be done. So 6 upgrades in a single maintenance window just to avoid hitting 4 bugs. There's also 2 i40E NVM firmware upgrades. This is where it also gets even further interesting. 6.01 needs 3 reboots per routing engine to implement. And the best part, you actually have to cut power to the routing engine. You can't just reboot it. And I want to say a special thanks to Lindsay Hill. I don't think he's here, but at 32590 Valve, he wrote a blog on this, and I found it in my investigations, and he helped me get this implemented. So you can actually power these routing engines off using the CB shutdown command and shut down the power to the CB. The CB shuts down the RE, power it back up, happy days. If you have dual REs, it works great. If you don't, you're getting someone on site to do this. So 14 reboots in total are required to complete the full upgrade cycle. It's about 16 to 18 hours. I don't know if any of you have ever tried to copy Junos or any other operating system to a network vendor's device. It takes hours. You can have the highest speed link in the world. It's never going to work effectively. We could ship USBs around the country until a USB fails, and then we have to deal with that mid-upgrade, and the box is bricked. So it's not going to fit into a 12 a.m. to 6 a.m. maintenance window. That's really going to upset customers because they expect that in the morning they can browse Facebook, they can browse Google, whatever they want to do. It will work, hopefully. The standard upgrade path looks like this. So 18.4, 601 NVM, that's 3 reboots, Junos 19.3, 22, version 7 for the NVM firmware, 21.2, and then 22.2 finally. In total, that's a lot of reboots. And I should note that reboot figure, if I go back actually, that's for single RE, dual RE, you double that number. So we worked with our vendor to come up with an expedited upgrade path. We tested it ourselves, and we also worked with them to validate that this is something they had seen before. It is supported in some sense. It is always recommended to test this yourself, however. We would pre-upgrade these routing engines in our Melbourne lab. We would ship them to the actual site and schedule a window to replace the routing engines by doing a physical swap on the RE that had been upgraded. At this point, it means there's also no requirements to adhere to the incremental upgrades, And it mitigates the risk of the 4 PRs and potentially any other bugs, and also means we don't have to schedule a second outage window to further upgrade to our final version. All the upgrade work itself, which is the really long, drawn-out process of having to test it and make sure it's going to work, which is high risk, especially when you're doing this many versions, it is done in a lab environment. So there's no impact to the production network, except for approximately a 15 to 20-minute window where the FPCs reboot to do a microcode upgrade. And interestingly, one thing we wanted to know is, can it be rolled back by reinstalling the non-upgraded routing engines again? In our testing, yes. Now, it may not always work. There was a caveat that there may be microcode incompatibilities at some point, something you should test yourself. However, in our experience, in our case, we were able to install them again in the lab and find that the network would reboot on 18.4 again, which was great for us. It means there's only 2 reboots of each routing engine, and the reason being is, in this case, you need to install the routing engine, load the configuration on it prior to installing the new routing engine, so from the old one, and then you need to also enable enhanced IP services, which requires a reload again of the routing engine. Make sure you don't miss that step, and I'll talk about that in a little bit too. So we'll fit this in a 12 a.m. to 6 a.m. maintenance window. In our testing, it only took about 2 hours to do this whole process, including pre and post checks, and ensuring the network returned to its full operating capacity. There is one downside. It's a big bang approach. 4 major releases in a single reboot. There's a higher risk of something going wrong, and if it does go wrong, we're talking about basically what is an essential service these days. Let's be honest, people wake up, and I think since the days of COVID, we've all found that it's far more critical to have an internet service when you wake up in the morning than it used to be. And this is what it looks like. So it's a much simpler step, 2 reboots each, total of 4 reboots, happy days. So to lab the upgrade, we basically test the upgrade process, which interestingly is actually just either the incremental or a USB upgrade step in the lab to load that new version onto it. We validate the software's working, effectively a bug scrub. We need to test the network, make sure it's going to work, make sure the network is stable, the tunnels come up, whatever we need to do. And our lab is actually a replica of our production network, albeit at a much smaller scale. So we do simulate the full ONU path through an OLT in a GPON network with splitters, with attenuators, whatever else we need to do in the lab, all the way into a PE router back to our core network in the lab. So this gives us a really good view of what it will look like in our production network. We need to document the upgrade process, including the physical swap out. We're going to have people, as Tim last talked about, in a facility in the middle of the night, uncaffeinated or maybe highly caffeinated, buzzing, shaking, and we need to have a document that they can follow, both the engineers and our field team, to ensure that we do the right thing. It also gives us the ability to validate the time constraints that we'll have. Does it actually fit into the maintenance window? If something goes wrong, how long do we need to troubleshoot it? Is 6 hours enough? Do we need to start it earlier in the night? And we did find that it was plenty. As I said before, I think it was about 2 hours each upgrade. We also test that the i40E and VM firmware upgrades were not tied to a chassis in any way, shape or form, or there was no weird issues or things that may occur when we swap a routing engine over that's been pre-upgraded, and we found no problems with that. The biggest thing, configuration changes, syntax changes in the code, breaking changes that may be a default behavior change between releases. Is there some kind of config that's going to go missing when we try and load the config on, or not commit properly? If we did find those, we just simply need to document those, and they'd form part of our change process. Again, through our change management process were these upgrades implemented. So we had a step-by-step path that we had to follow. We build a list of validation commands for pre and post checks. Again, Tim, I think I'll be chatting to you after this conference. We bug scrub and validate for any longer-term memory leaks, because this is something that can bite you. It's great to say the network is working right now, 5 minutes after I've upgraded it. How is it working in 5 weeks' time? So we left this running for the rest of the year, including through our embargo period over Christmas, and came back in the new year seeing that the box was operating correctly with no signs of memory leaks. We'd also need to reboot the devices at the end of that to ensure that there was no configuration loss or boot issues. Last thing you want is to have a power loss in a facility and find out that your router no longer powers on properly anymore, or your configuration goes missing after you reboot it. So our deployment plan needs to factor in logistics of shipping equipment around Australia now, however. And I'm from Darwin. I'm used to shipping taking a very long time, usually weeks, sometimes months. It usually gets from the US to Sydney quicker than it does from Sydney to Darwin. However, I wasn't expecting the same thing to occur around the rest of the country. We did find that it generally can take quite some time via road, and via air, it's very, very expensive to do this. The other factor you have is you're shipping very expensive components around the country now. You need to make sure they're insured properly. So documenting our implementation plan also needs to form this, our test plan, our rollback plan, and then ensure that we peer review this so that me or whoever, another engineer in my team, we haven't made a mistake along the way. Sometimes it's really easy when you're dealing with complex tasks like this to get tunnel vision and forget something so small, and a quick peer review can solve that problem. We also need to notify the RSPs about the upcoming network maintenance. We are, like many carriers, we're actually contracted to deliver a minimum lead time for outage notices, with exception to emergencies. We certainly don't want to be treating software upgrades as an emergency because of a lack of our planning, so we need to plan when we're going to send these advisories out to our carriers, who can then send them on to their own customers, the end users. We'd also need to pre-book field engineering resources who can sometimes be quite hard to get because they're doing a lot of fun stuff like building the new network or troubleshooting faults day to day when the network is failing or things are going down. So we need to make sure they're aware there's a lot of upgrade work and a lot of late night work coming so they can plan for that adequately and ensure there's the right resourcing. We also need them to go to the site and make sure that they check things like, is there a weird cable in the way that someone has not cable managed properly and you can't pull out the routing engine anymore? Don't want that in the middle of the night. Or strip screws, I should say. We need to also mitigate the risk of a large volume of support calls if something goes horribly wrong. This is something that can be often forgot about, is your poor ops team, when it doesn't go to plan, suddenly the phone rings thousands of times. So we did this by bolstering our NOC shift staff every time we did an upgrade, ensure that there were adequate staff members to account for any increased volume in workload if required. And for our first upgrade, we had JTAC on the call with us. We need to prepare the configuration backups. On the night, we do the pre-checks. We'd actually implement the change just by swapping the routing engines. We run our post-checks, and we monitor the network and then hand it over to the NOC shift staff. And I've basically, in one sentence, summed up what we did on the night and our whole upgrade process effectively. And it sounds really simple, but it's because of all the forward planning in our lab that it seems so easy. And this is actually what our production timeline looked like. We presented this to the executive team to ensure they were also happy with it. We chose to do this in our secondary POI, which is a much lower traffic volume in Victoria first. These are Opticomm site codes. You may be able to decipher some of the facilities they're in. If you can't, they're on our legal page in our technical documents. But essentially, our small Melbourne site, and then the second site we did in the 15th of February was our largest site, which is New South Wales, our primary POI that was crashing. This is the one we had the biggest problems with. And then we proceeded on with every single secondary POI to give us extra time to ensure that if we did encounter any weird issues, there was only one of our primary POIs that had been upgraded. And we took that as a bit of a risk assessment that we needed to do New South Wales because it was experiencing the problem. It was the only site experiencing the problem. And although we know that it was potentially risky doing a primary POI so close to the beginning of the upgrade process, it had to be done. And then, of course, throughout May to July, we completed all of our primary POIs in South Australia, Perth, Queensland, and Melbourne. And the great thing about all this is it worked, as simple as that. So we're now running new code. We didn't have any issues along the way, and everyone was very happy. We do still have some niggling issues here and there, but we don't believe they're related, and we don't believe we've encountered any further scaling problems or bugs at this point in time where we need to mitigate the risk further at this point. That may change soon. And yes, before you ask, we are considering design changes of our network as well. So some of the lessons learned and recommendations, obviously I mentioned this before, the cost, the reliability, the distance, the time, and the insurance for shipping equipment around Australia, you need to factor that in. It's a big thing. These devices, if they go missing, the bean counters are going to come knocking. It's something they don't want to see going missing, that's for sure. Build a life cycle plan for your network and stick to it. This is something that I don't think we've done great and something that we're owning and have implemented now. We're regularly testing new releases in our lab in advance of a plan to upgrade to ensure that if we do encounter a problem, we've already completed most of the steps I've just been through and could very quickly run out the same deployment plan that we went through. Make use of a lab that's a replica of your production network. It doesn't have to be the world's biggest lab. It doesn't have to span Australia. You could even start with Container Lab, as Tim mentioned before. It is something we have done. And we also then built the physical lab to ensure that we could accurately test it. But I can't stress how important this is. Find a way to convince your bosses, or if the bosses are here, trust me, it's great. It certainly reduced my stress levels. So support your team in this. Regularly test the new software versions, obviously, as I mentioned. And the biggest thing is build a good change management process. That way, when something did go wrong, we could very quickly determine it wasn't our mistake, it wasn't a human error, we followed the right steps. Make sure you review your vendor and bug information, documentation. That gives you all the information about breaking software changes or breaking syntax changes, and also the 4 PRs we identified were very well documented. And if you do identify bugs or PRs, don't just forget about them. Document them somewhere in your wiki or whatever you have. That way, when you do test the next software release, you can actually go back and review if they've been fixed. Something I think we're always trying to improve upon. Don't be afraid to implement a change freeze as well as a stopgap, or sometimes more permanently. This will help you maintain the stability of the network, at least in the short term, until you can work out an action plan. And communicate this effectively with your customers. It's something as well we didn't do great at the start. However, we did learn very quickly where we could improve. And it's something we'll take on board for next time, that when we implement a change freeze, we need to tell our customers. In hindsight, as I mentioned, we could have USB upgraded these. We hadn't actually tested it, but last thing I wanted is a USB failing mid-upgrade. Build a reliable out-of-band network, and I didn't talk about that much, but I think I can't stress how important it is to be able to have one. So if something goes wrong and you lose in-band connectivity to your device, you can see what's going on still. And last of all, make sure you buy your field engineers and network engineers a lot of Red Bull or coffee, especially after last night by the sounds. They seem to deserve it, and they work very hard. And I also want to thank my network engineers in my team who implemented this upgrade, because it was absolutely awesome. Lastly, I have provided our implementation plan, which is actually a step-by-step of every process, including disabling GRES, NSR, the whole thing. I'm not going to read it out today. These slides will be sent out, as I believe, as part of the slide and videos getting uploaded later. So if you do want them, let me know. And always, if there's any questions that are deeper than this afternoon, I'm happy to have you contact me directly. Otherwise, I might leave it to you guys to ask me any quick questions if I've got a bit of time.